Hi, I am Onimesh Haldar of Coach BR College. I am giving the teacher's presentation for the Faculty Induction Program 20. The topic I am going to discuss today is about the semiconductor, then P and N type semiconductor. After that, how P and N type semiconductor are formed and how P-N junction is formed. Now, as first, when we talk about the semiconductors, we know semiconductors is a kind of material. Mostly, the valency of this material is 4, and the superior semiconductors which usually we use is germanium and silicon in pure form. These are called the intrinsic semiconductors because these are pure semiconductors. But for the better conductivity, for the better result for the modern physics, we use extrinsic semiconductor. Extrinsic semiconductor means with the pure semiconductor we mix some doping. We use another some different type of material in the ratios 10 to the power 6 to 1, more or less. So 10 to the power 6 time is the ratio for the pure semiconductor and 1 for the doping. Now we will discuss how the doping is formed. So in this figure we observe that in case of extrinsic semiconductor there are two types of extrinsic semiconductor, P type semiconductor and N type semiconductor. Now in case of P type semiconductor with silicon, trivalent atoms or doping is done. In this case the doping element actually is the boron, and these are mixed with the silicon. And in case of N-type semiconductors, some pentavalent doping elements are mixed with silicon or germanium. Now, if we move to P-type semiconductor, we observe that as the boron has 3 valence electrons, so when they are making covalent bonds with the silicon, so one position is empty, so there is no electron. So if there is no electron, there is no bond formed due to a lack of one electron. This position is called the hole. Now what happens? This hole will be filled up by another electron, and when the electron leaves up this place, there a hole will be created at that point. So in such way, so hole is nothing but a positive. We can consider as there is in this place there is a lack of electrons, so the hole may be treated as positive charge. So what we observe that when the electron moves to fill from here to here, a hole will be created at this place. So there is an animated video for p-type semiconductor. Look, when this electron is coming here to here, this hole actually created at here. So actually this hole is moving from one valence position to another valence position. Now similarly, in case of n-type semiconductor, for arsenic there are 5 valence electrons. Now what happens? So there is one extra free electron is here, and these free electrons actually unused. When the temperature slightly rises, this electron actually comes out of the valence position and it can conduct like this. So what you observe that in case of n-type semiconductors, the electrons actually are responsible for the flow of current, and such thing happens. This electron is coming out, so this electron can create or can conduct electricity. So what we are observing in p-type semiconductor, the holes actually are responsible for the current, conduction of current. In case of n-type semiconductor, the electrons are actually responsible for the conduction of current. In the next slide we observe that how a p-n junction is formed. So a p-type material and n-type material actually they are joined. They are joined by melting, and after that a junction is formed. But when a junction is formed, several things actually going to happen. Now we'll show in through the animated video how a junction will be formed. Now in the p-type semiconductor, these blue dots are actually the holes which are the majority carriers, and these are the negatively charged ions. And in case of n-type semiconductor, these brown dots, these are electrons which are the majority carriers, and these are the positive ions. So when the junction is formed, what will happen? We will observe one by one. So when this junction is formed, there is p-type and n-type junctions actually are fuse together, at first some electrons as well as some holes as well as some negative ions will come from left to right like this. Similarly, also holes will come to the junction towards this. After that, for the n side, actually these are will happen simultaneously, but I am actually giving the demo one by one. After that, this negatively charged, positively charged ions are coming from right to left, and also these electrons are coming. So actually in this left side there is a deposition of some bulk negatively charged ions, and in the right side there is some positively charged ion. And after that, when the electron or hole recombine together, so they will vanish actually. So nothing, the no charge will be left in the depleted region. Only some positively charged bulk ions at the right of the junction and negatively charged ions at the left of the junction. And in the mid section there will be recombination of electrons and holes, and the charges will be actually vanish. So as the middle section is depleted of any charge, so this is called the depletion region. So in this way a junction is formed. So after that, what will happen? This electrons will actually recombine, and there will be no effect of the charges. Only these positively charged ions and negatively charged ions will be there. So after this, due to this, there will be no actually flow of further electrons and holes. So after that, the diffusion will be stopped. Now after that, so as the deposition of positive charge is here at the right of the junction, negative at the left of the junction, so actually a barrier potential will be formed, and this barrier potential is, and also a depletion region will also be formed. Depletion region, actually it is the depletion of charges, that is the charges depletion of the majority carrier charges. Only there will be exist as a positive and negatively charged carriers. Okay, after that we know, and this potential barrier actually the actually the measured value approximately for germanium, this potential barrier is of 0.3 volt, and for silicon it is 0.7 volt. And if we try to plot the barrier potential from taking this line, this PN junction as origin, and if we plot the barrier potential towards positive and negative direction, this will look like this. So by this way, so in this way a barrier is formed inside a PN junction. And if you we actually at the unbiased condition, there will be no flow of charge carrier. So this is the actually my presentation, and thank you. Thank you, sir.